Shall we start the class? Shall we?
Yeah, sir.
Okay. Steam power plant incorporates an ideal reheat cycle to improve the existing efficiency. So if any of the power generating system, if any of the cycle is incorporating a reheat philosophy, then what are the changes that we can expect? Yes, what are the changes that I can expect? So naturally, what would happen is, this is the thing which was naturally happening, isn't it? Okay, so from 4 to 1, there was a heat addition process which takes place in three different categories. After that, 1 to 2 was turbine expansion, 2 to 3 was condensation, and 3 to 4 was the pumping work. So this is a normal thing. So if he says a reheat 1, then what actually happens? Can anyone say that?
One dash, it increases.
What increases?
The temperature.
Okay. So I will just revise the concepts. The basically 2 to 3 different methods of improving the efficiency of work output of these cycles. Number one is by regeneration, where you'll be sending a part of the steam intermediate of the expansion to heat the fresh incoming water. So that is what you are doing in case of the regeneration. In reheating, what you are doing? Anyone? Okay, so in reheating, what you are doing is, I've just explained you. So there will be a turbine. Okay, so whatever the expansion will happen from one turbine, that will be sent to another turbine. Okay, so there would be totally two stages of expansion. So the first one is known as high pressure turbine HPT, and the second stage of turbine is known as low pressure turbine. So between these two, there would be a component which would be introduced. For example, which is this. So what is
Reheat.
this component? What is this component which is introduced between high pressure?
Reheater.
Exactly. So that
Reheater.
particular thing is known as the reheater. So this is what a reheating Rankine cycle is all about. So what happens? So what necessary changes I have to make in my TS diagram to this particular condition? So what whether 4 to 1 will change?
No, sir.
Whether 1 to 2 will change?
Yes.
Yes, yes.
Yeah,
Yes,
sir.
definitely it will change. So I will just change it up. Okay, I'll just change all these things. Okay, so 1 to 2 will change. It will be not more 1 to 2. Rather, it gets expanded in two different stages. So how it get expanded, we have to understand by looking into the further statements of the problem. For example, so he says steam at 30 bar and 250 degrees centigrade is supplied to a high pressure turbine. That means these particular parameters, can I say it as P1 and T1? Can I say these as P1 and T1?
Yes.
Do you require this diagram? It's okay. I'll just paste it aside. Okay. So the pressure at these lines, that means this isobar is there, no? This particular isobar has a pressure of how much? It is 30 bar. So I will just indicate with the red line so that it would be easy for you to understand it. Okay, like this. So all these isobar, this particular isobar like this. Okay, how much is this? All this is 30 bar. Okay, is that clear? And 250 degrees centigrade, can I take it as T1, which is equals to 250 degrees centigrade, right? To a high pressure turbine. Next, inlet. This is inlet, okay? Inlet, okay, fine. And expands till it is, now I want you to answer this. I want you to analyze this and answer this. And he says, further he says, high pressure turbine, after high pressure turbine, in the high pressure turbine, the steam expands till it is in dry saturated at 3 bar. So till where the steam expansion takes place?
Vertically till it touches that line.
Till where? Till where? It will move on?
Till
It will
that
move on?
curve. There only, sir.
It will move on?
No, no.
Then till where I should move this? Where the
Vapor.
till where the expansion takes place?
Saturated vapor line.
Till it touches the
Saturated
saturated
vapor.
vapor line. That is what he is meant. How did you come to know that it is touching the saturated vapor line?
Till dry saturated it is
Very
moving.
good. So he has used the word dry saturated. So it gets expanded till it is in dry saturated, and at, even he has specified what is the pressure? 3 bar. Is that clear?
Yes, sir.
Very good. Now, what happens next?
Temperature will increase.
Yes, the steam is taken to a reheater. The steam is taken to a reheater and its temperature is again increased to 250 degrees centigrade. So now reheating happens, reheating in the sense superheating. So like this heating happens until where it happens? Until where?
250 degrees
Until where?
Celsius.
250 in the sense, should I match this particular point? Now it is okay?
Yes, sir.
Now it is okay? I have matched, see, 250, 250. Understood, everyone?
Yes, sir.
Okay, now. Okay, good. So from there, what happens? So it has reached the 250. So now I will give the state points here. Okay, so I will just manipulate the state points afterwards. Okay, I'll just rename the state points. Okay, fine. So next, again increase to 250 degrees Celsius at a constant pressure, he says. At a constant pressure in the sense, see, what was this pressure?
30 bar.
No, 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 no. This one. What was this
3
pressure?
bar.
3
3
bar,
bar.
isn't it? From 3 bar, it is getting reheated, 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 reheated to reach 250 degrees Celsius back again. Correct? Correct? Yes or no?
Yes. Yes, sir.
Now, if it is going to 250 degrees Celsius like this, he says it is going in a isobaric way, isn't it? That means he
Yes,
says it
sir.
is in the constant pressure. Then can I take the pressure at this particular isobar, which I just am marking with purple now, as 3 bar?
Yes, sir.
Understood, everyone?
Yes, sir. Yes, sir.
That means the pressure at all these points would be 3 bar. The pressure at all these points would be how much?
30 bar.
30 bar. Very good.
Sir, why
Next.
did you draw a different line, sir? Different violet line, purple line.
So just to indicate these states are at the different pressures, I have used red to indicate all these points which are there in red color are at 30 bar. These are 30 bar pressure. Now, in the same case, after expanding, the pressure drops, isn't it? The pressure drops. Again, you are reheating, pressure drops to 3 bar. Again, you are reheating to a constant pressure. That means even this is also at a constant pressure. So, pressure at all these points would be same, which is 3 bar. So, I have
Yes,
to
sir. Yes.
indicate, no? That is why I have differentiated with both the colors so that you get identified it soon. It is not necessary to draw this dotted colored lines, man. It is for my explanation for your understanding, both the ways. Is that clear?
Yes, sir.
Good. Now, from here, after this thing, reheating, after reheating, what happens now? Reheating process. The reheated steam expands in a low pressure turbine at a condenser pressure of 0.04 bar. That means this particular thing will get completely expanded until it reaches a condenser pressure. Okay, until it reaches a condenser pressure. So what is condenser pressure?
Point zero bar 4.
0.04 bar. Okay, from here it is again pumping work, going back to normal stage like this. So the pressure for this I would indicate in the blue. So condenser pressure, in the sense it is this particular pressure. So all this will remain at a constant pressure. And this particular pressure is how much?
Point
0.0.
zero 4 bar.
0.04 bar. Very good. Now I will indicate states now. It's up to your convenience. You can use A, B, C, D. You can use 1, 2, 3, whatever it is. Even you can use Kannada also. Kakka gaggana itru samasya agalla. Okay. 1, 2, 3, 4, 5, 6. I always follow A and B for this. Is that clear? Any doubts?
No, sir.
So this is the overall problem transformed into a TS diagram like this. Okay. Now, once it is getting transformed, now we shall see what he has asked. Okay. So even I would write it here. So this particular thing, T1, which will be equal to T3, that's just 250 degrees centigrade. When you convert into Kelvin, it is 523 Kelvin. Very good. Now, determine the cycle efficiency, he says. That means we have to determine efficiency of Rankine cycle. It's again the same thing. It's again the same thing if you go with the basics. Go with the basics. You will be, you can find this without my help. From now on, you don't even require my help to calculate whatever it is required. Okay, it is very easy. Go with the basics, I say. Okay, so now TS diagram we have drawn. Now, how do you calculate the efficiency of any cycle? Of any cycle.
Output.
Very good. It's just output divided by input. So output here is nothing but the total work output, whatever you are getting. Input is nothing but the total heat which you are supplying. Correct? Now, how many work dones are there? Come on, you have to identify how many
Turbine work.
Very good. There's a turbine work. Only one turbine work.
Two.
No, so two turbines are there.
So two turbine ಇದೆ. So I would just write HP plus turbine work LP. ಎರಡು ಟರ್ಬೈನ್ ವರ್ಕ್ ನ ತಗೊಂಡಿದ್ದೇನೆ. ಇನ್ನು ಯಾವ ವರ್ಕ್ ಇದೆ?
Pump.
Pump work. Okay. So that's all. Any other work is there? So three works are there. 1, 2, 3. Correct? Any other
Yes.
works? Very good. Now heat addition processes. I mean, heat supply. Heat supply ಎಲ್ಲಿಂದ ಆಗ್ತಾ ಇದೆ? ಎಷ್ಟು ಕಡೆ ಆಗ್ತಾ ಇದೆ? ಅವೆಲ್ಲ ಬೇಕು. Now, heat supplied.
6 to 1.
Very good. So heat supplied is from 6 to 1. Only one heat supply?
4 to 5.
Where 4 to 5? 4 to 5 heat rejection. You are rejecting the heat in the condenser. You're not supplying anything. When heat supplied ಮಾತ್ರ ಬೇಕು.
Sir, 2 to 3.
So 2 to 3.
Sure? Sure?
Yes.
Yes, sir.
Very good. So now KIF 2 to 3. Even you are supplying heat over there. That means you are supplying heat 1 from 6 to 1, which is conventional economizer, boiler and superheater. You are using that. Second, you are supplying heat from 2 to 3 by means of a reheater. Okay. So two heat supply. ತಗೊಳ್ರ ಟಕ ಹೇಳ್ರಿ ಈಗ WT HP turbine. So high pressure turbine expansion happens from where to where, whether from 1 to 2, 2 to 3, 3 to 4, what it is. High pressure turbine.
1 to 2.
1 to 2.
So W1 to 2. So how do you calculate W1 to 2?
H1 minus H2.
It is for work, it is initial minus final. So it is H1 minus of H2. That's it. Now, WT LP. So where it is low pressure
3 to
turbine
4.
happens.
3 to 4.
Very good. It's from 3 to 4, which is here. Correct? Now, that is equal to H initial minus final. So it is
H3 minus H4.
H3 minus of H4. Very good. Now, pump work. So pump work happens from where to where?
5 to 6.
It is W 5 to 6, which is this, right? Okay. So initial minus final for work. So it is what minus what?
H5 minus H6.
Very good. Now come to the heats now. For heats, you have two heats to be calculated. Give 6 to 1, okay, which is the general heat which you are giving through all these components. Okay. 6 to 1 in the sense for heat, it is final minus initial. So it is
H1 minus H6.
H1 minus of H6. Okay. Now, one more heat you are supplying. Where you are supplying?
2 to 3, sir.
We are supplying from 2 to 3. For heat, it is final minus initial. So it is what?
H3 minus H2.
It is H3 minus of H2. Very good. Okay, did you understand? So if I am in a position to calculate H1, H2, H3, H4, H5 and H6, then can I calculate the Rankine's efficiency?
Yes, sir.
Can be.
So that is all the problem for you. That is all the problem. Okay. So how can I increase the complexity of this particular problem? ಈಗ ಇದು ಒಂದು ಲೆವೆಲ್. ನೆಕ್ಸ್ಟ್ ಡಿಫಿಕಲ್ಟಿ ಲೆವೆಲ್ ಹೇಳ್ತೇನೆ ನಾನು. ಹೇಗೆ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ HP ಟರ್ಬೈನ್ 80% ಅಂತ ಕೊಟ್ಟಿದ್ದ. ಸೊ ವಾಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡನ್? ಎನಿವನ್ ವಾಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡನ್?
2 dash.
2 dash would come. So this would shift because efficiency is given. This would not go in a generic way. It would move something to 2 dash. Now I need to calculate H2 dash here, isn't it? ಇನ್ನೂ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಏನ್ ಮಾಡ್ತಾರೆ? ಇನ್ನೂ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬಹುದು. ಹೇಗೆ? ನೀವೇ ಹೇಳಿ. ಹೌ ಕ್ಯಾನ್ ಐ ಇನ್ಕ್ರೀಸ್ ದ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್? ಕಮ್ ಆನ್.
Efficiency of low pressure turbine.
ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಲೋ ಪ್ರೆಷರ್ ಟರ್ಬೈನ್ ಕೂಡ ಕೊಟ್ಟಿದ್ದ. ಸಪೋಸ್ 85 or 80% ಕೊಟ್ಟಿದ್ದ. ವಾಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡನ್ ಫಾರ್ ದಟ್?
4 dash.
So 4 dash, it would not go in a straight line from 3 to 4. It would deviate to a certain part like this to meet at 4 dash. So you might have to calculate H4 dash over there. ಇನ್ನೂ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಏನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ?
Efficiency of the pump.
Efficiency of the pump ಕೊಟ್ಟಿದ್ದ. Very good. Efficiency of the pump ಕೊಟ್ಟಿದ್ರೆ it would not go from 5 to 6 in a straight line. Rather, it would deviate something like this to meet at where? To meet at 6 dash. ಇನ್ನೂ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು.
Regenerative efficiency.
There is no regeneration. I think you're talking about reheating.
Reheating efficiency.
So reheating efficiency ಕೊಟ್ಟಿದ್ದ. So effectiveness of reheater ಎಷ್ಟು? 80% ಕೊಟ್ಟಿದ್ದ. So if it has given the effectiveness of a reheater, what you have to do? It would not go as indicated from 2 to 3 like this. Rather, it would deviate something like this to meet at 3 dash. So you might have to calculate H3 dash then. ಇದಕ್ಕಿಂತಲೂ ಇದಕ್ಕೂ ಮಿಗಿಲಾಗಿ ಏನಾದ್ರೂ ಕಷ್ಟ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನಾ?
Sir, if it comes, it will be for 20 marks, no?
Definitely. It will not come by the way. I'm just training you for the verse. Keep this in mind. I'm just training you for the verse. It will never come all this stuff, man. Either efficiency would be given for a normal vapor cycle. I'm training you for the verse. That is what I'm trying to say. It would be hardly 8 to 10 marks problem. That's it. So by the answers, whatever you are giving, I am satisfied that you have understood the concepts of vapor power cycles. Correct?
Yes, sir.
Are you feeling confident on that?
Yes, sir.
Yes, sir.
Okay. Yes. Okay. Shall we start now? The present
Yes, sir.
problem I've just made normal. Okay, now. So we have to calculate. We have to calculate. Images better. Okay. We have to calculate all H1 to H6. So this would be fun. So please cooperate and give me the answers very fast. Okay. I would go to the next page. Okay. Just place it here. Now I must calculate the value of H1. So where is H1? So I have to look for state 1. Where is state 1? Where is state 1?
Superheated.
It is in superheated state. So if it is in superheated state, I already told you I have two options that I can go for. I have a formula and I have a table. So which to choose now?
Table, sir.
Table. So I would just choose a table. Okay. So go for the superheated tables over there. At what pressure? At what pressure should I look for? What is the
30
state
30
1
bar.
pressure?
30
Very
bar.
good. So P1 is 30 bar. So at P1 equal to 30 bar, what is the value of H1 directly from the steam tables? Please let me know.
2854.8.
2854.8. Even I guess you might have to have the value of temperature as well, right?
Yeah, sir. Without
To get
value
the,
of temperature, we can
we cannot have it. So what is the temperature?
250.
Yes,
Yes.
it is 250 centigrade. Okay, now I have the calculated value of H1. Let us move to H2. So H2. So H2 is in which state?
On the vapor line.
Very good.
Right.
It's on the vapor line. So if it is on the vapor line, then
G.
H2 will be equal to
HG.
Hg at pressure of what? At pressure of
Bar.
P2.
3 bar.
P2 is how much?
3 bar.
3 bar.
Very good. So it is 3 bar. Now at 3 bar, can I get the value of H2?
2724.7 kilojoules per kg.
2724.7 kilojoules per kg. Very good. Now, let us move to H3 now. So H3 is again, it is where?
Superheated at 250
It
degrees
is in a
Celsius.
superheated state. But what about the pressure? So you are going with the tables to find out,
3
right?
bar.
But now, what
Yes,
is the
sir.
pressure? Pressure has changed. Pressure is
3
3
bar.
bar. Temperature is same. Temperature is 250 degrees Celsius. Now, can I get for this combination of pressure and temperature, what is the value of H3 directly from the steam
296.
tables? 21
2967. 2967.
2967.9,
9.
correct? Right. Correct. Now, H3 is done. Now, H4. So, H4 is in which state?
H4.
H4 is in which state?
Wet
It's in wet
wet
region.
region.
Okay. If it is in wet region, how will I calculate my H4?
HF plus XSFG.
HF plus X into HFG. So all these values need to be at state 4, right? Now,
Yeah.
taking HF and HFG at P4, which is equal to what is the pressure at state 4?
0.04.
So 0.04 bar. Please give me the values of HF and HFG.
Two four three 3.1.
What is that?
HF And HF is 1 to
HFG.
1.
Okay, fine. So HF and HFG. So HFG is 2433.1. And what about HF?
1 to 1.4.
It is 1 to 1.4.
4.
Both are based in kilojoules per kg. Kilojoules per kg. Very good. So HF and HFG we have found out. So if I substitute back, it is 121.4 plus X4 into HFG. Now what should I do in order to calculate the value of X4? What is the trick that I have followed and I have taught you?
Entropy.
We have to consider an isentropic expansion. So which expansion to be followed? Whether to take 1 to 2 or 3 to 4 here in this case.
3 to 4.
Very good. So 3 to 4 is isentropic expansion. So that is why S3 would be equal to S4.
S4.
Am I right?
Yes, sir.
Now, next. S3 in the sense, what is S3? Which region? S3 is in which
Superheated region.
It is in superheated region. So can I get the value directly from the steam tables for S3 for that particular pressure and temperature? I will just measure reference pressure. So that is P3 is equals to 3 bar and T3 is equals to how much? 250 degrees centigrade. Can I have the value of S3 directly from the steam tables?
7.5176.
It's content outside the page. And just a minute. Okay. How much?
7.5176.
7.5176. That is equals to. Now, coming back to S4 here. S4 is in which state?
Wet region.
It is in the wet region. So if it is in the wet region, how will I calculate my S4? How will I calculate my S4?
SF plus X into SFG.
X into SFG. Can I have the value of SF and SFG at P4, which is pressure of 0.04 bar? Can I have those values? Can I have those values?
0.4225 SF.
0.4225. So this would turn to X4 since it is at the state 4. Now what about SFG?
8.0530.
8.053. Okay. From this, can I have the value of X4? I want others to answer. Hashir, Hazim, Sushant.
0.88, sir.
How much?
0.88.
0.88. Now, once I got the value of H4, I think you can calculate the value of H4 now. Okay, substitute the value of X4 there. So that is equal to 121.4 plus X4 is 0.88, just you have calculated, into HFG. HFG, I have to write it here. What is that value? It is 2433.1. So it is 2433.1. And this, whatever value you get, that is H4. kilojoules per kg.
2264.96.
Yes, Sushant, how much it is?
64.96.
224.96. Now, immediately jump on to H5 now. So, how will you calculate H5? So, H5 is in which state?
Saturated liquid line.
Yes,
Saturated
it's
liquid line.
on saturated liquid line. So if it is on the saturated liquid line, which is here, H5, so how will you calculate H5?
H5 is equal to HF.
It is HF at state 5. What is that? P5. So P5 pressure is again, it is 0.04 bar. Even this is at constant pressure. Okay, fine. So now, what is HF at P5? That is 0.04 bar. That is nothing but H5.
121.4.
121.4 kilojoules per kg. Now, the last thing, which is H6. So, H6 is on liquid region. So, if it is in the liquid region, what is the trick that I have given you to calculate the value of H6, which is in the liquid region? If it is in the liquid region, what is the trick that I have given you to calculate?
WP.
Yes? So we need to calculate pump work. We need to calculate pump work. So how do you do that? So WP is given by, so it is 5 to 6, right? W 5 to 6. So either it is given by H5 minus H6. Either way, it is given by V5 into initial minus final. That is P5 minus P6. It is P6 minus P5. Okay, pressure. P6 minus P5. Now, how to get the value of V5, which is on the state 5. So state 5 is on liquid line, saturated liquid line. So if it is on the saturated liquid line, how do I calculate P5?
ಸರ್ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ P3 ಮೈನಸ್ P4 ಮಾಡಿದ್ದು ಸರ್.
ಅದೇ ನಂಗೆ ಡೌಟ್ ಆಗ್ತಿದೆ ಕಣ. ನನಗೆ ಒಟ್ಟಿನಲ್ಲಿ ಆನ್ಸರ್ ನೆಗೆಟಿವ್ ಬರಬೇಕು. P5 minus P6 ಅಲ್ವಾ? ಕರೆಕ್ಟ್. ನನಗೆ ಅದೇ ಕೊಡ್ತಾ ಇದೆ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನವ ರಾಂಗ್ ಕೊಟ್ಟಿದ್ದಲ್ಲ. P5 it is always initial minus final ಅಲ್ಲ ವರ್ಕ್ ಅಂದರೆ. Yes, now it is correct. What is B5? At state 5, which is on the liquid region, sorry, liquid line. So which is equal to the value of VF at pressure of state 5.
Zero
Pressure
point
of state
zero
5 is 0.004 bar. Now, what is this?
0.001040.
Okay, fine. So now P5 and P6 you know, so just substitute there. So WP, which is equals to W5 to 6, that is equals to H5 minus of H6, that is equals to V5. We have just calculated it as how much? 0.001040 something, okay, into P5. P5 in the sense it is 0.04 into 10 to the power of 5 minus of P6. P6 is at 30 bar, so it is 30 into 10 to the power of 5. So this would be equal to how much pumping work? Pumping work?
minus 3007.98.
3000, ಇನ್ನೊಂದ್ಸರಿ ಹೇಳು.
minus 3007.98.
3007.98.
98.
Can I just write it as joules per kg? So whatever you get here, it would be in joules per kg. So generally, we are following kilojoules per kg, no? So because H5 and H6 are in kilojoules per kg. So how do I convert into kilo? So it is minus 3.007. 98 then I will make it 8. Okay. It's 3.008 kilojoules per kg. Am I right?
Yes.
Okay. Now, so just pick that particular value, it is minus 3.008. So now from this, can I have the value of H6?
One 124.408.
Okay. So it is 124.
4. 124. 408.
124.408. Now calculate all these efficiencies, I mean all this work done since you have calculated values of H1 to H6. Okay. Okay. Can I have the final values of all this? So all these values would be in what? Be in kilojoules per kg. Yes, can I have the values? WT, WTHP, WTLP, WP, Q621 and 223.
Sir, high pressure turbine work 130.1,
130.1,
202.94,
so this is minus 3.008.
2730.39, 392. Minus, no sir, minus 256.8,
ಏನು
Q223.
ಮೈನಸ್ ಅಲ್ಲಿ ಬರುತ್ತಾ?
ಹಾಂ ಸರ್.
ಓಕೆ. If 2 to 3, final minus initial, H3 minus of H2. H3 ಎಷ್ಟಿದೆ? ಓಯ್ ಇದು 2967 ಅಲ್ಲ, ಅದು 27 ಮೈನಸ್
ಸರ್ 243.2 ಬರ್ತದೆ ಸರ್, ಪಾಸಿಟಿವ್.
ಎಷ್ಟು ಬರ್ತದೆ?
243.2.
243.2. ಆದಿತ್ಯ
ಸರ್ ಅಲ್ಲಿ ಅದು ಲೋ ಪ್ರೆಷರ್ ಟರ್ಬೈನ್ ವ್ಯಾಲ್ಯೂ ಕೂಡ ನಂಗೆ 702 ಬರ್ತುಂಟು ಸರ್.
ಅದು ಸರ್ ನಾನು 2467 ತಗೊಂಡೆ.
2467 ತಗೊಂಡಿದ್ಯಾ? ತೊಂದರೆ ಇಲ್ಲ, ಅದು ನಾನೇ ಸರಿಗೆ ಬರ್ದಿದ್ದಿಲ್ಲ ತಗೋ. ಇದು 24 ಅಂತ ಕಾಣ್ತಾ ನಿಂಗೆ? ದಿಸ್ ಇಸ್ 9. ಓಕೆ, ಕರೆಕ್ಟ್ ಮಾಡೋದಿತ್ತೆ ಅವನ್ನೆಲ್ಲ. ಹಾ, ಸೊ ಈ ಆಲ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಕರೆಕ್ಟ್. Are all values are correct? Whatever is being written. Now, if yes, give me the efficiency for which we have struggled so much. Yes. ಎಷ್ಟು ಬಂತ efficiency? In 50% ಬಂತ, 60% ಬಂತ, 99% efficiency. ಸೊ ಎಷ್ಟು ಬರಬೇಕು ಅಂದಾಜಾಗಿ? ಇಷ್ಟೊತ್ತಿಗಾಗಲೇ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿರ್ತದೆ.
Below 30.
ಅಂದಾಜು ಇನ್ ಅಂಡ್ ಔಟ್ 30 ಬಂದ್ರೆ ದಟ್ ಇಸ್ ದ ರೈಟ್ ವ್ಯಾಲ್ಯೂ ಬಂತು. ಎಷ್ಟು ಬಂತು ಎಫಿಷಿಯನ್ಸಿ? ಐ ಆಮ್ ಕ್ಯೂರಿಯಸ್.
Sir, 27.9.
Okay, 27.9. Superb value. Textbook answer is 28%. Huh? Is everyone getting the same value?
Yes, sir.
Okay, what about others? Same value. Okay. Okay. So, is that enough that we have solved this particular problem on reheat and then shift to regeneration, or whether should we solve one more problem on this? So it's up to you. How you say? We will do it in the same way. So only problems on reheat and regeneration are being left over
Reheat.
to learn. Regeneration.
We'll go for regeneration.
You go for regeneration. What about others?
Yes, sir.
Straight away regeneration. Understood reheat?
Yes, sir.
Yes, sir. Yes.
Regeneration. Okay, in the next class. So I will just give you a problem enough. Keep it with you. Those who wanna try that they have learned or not. Okay, they can just try this form. So whatever the problems we have solved in today's class, so that you can just scan it and submit as a classwork in Google Classroom. So that would be regarded as attendance for today. Okay, 27.9. Okay, they can take a screenshot of this. I'll just wait. I'll just put in the right order. Okay. Yes, hope it's clear now. Okay, so just try this particular problem. It is very, very similar to the previous problem, what we have solved, and whatever the problem we have solved in today's class, the same problem you can scan and submit in your Google
Excuse me, sir.
Classroom to get that attendance. Lucky.
So can you show previous problem, sir, please?
Sure.